one more application of calculus, finding a max and mins, also called local extrema, also called optimization. So first of all, the geometry definition. A maximum is a hilltop, and a minimum is a valley bottom. And that's how you define them. So if you look on the vertical axis and you're plotting all the numbers, the maximum and the minimum are your lowest and highest number you plot. All pretty obvious, but you got to start somewhere. Looking at the input axis, the points where the max and min occur, those are going to be called critical points. Critical numbers, sorry. It was critical points when I was a kid, now it's called critical number. At the critical numbers, our slope is 0. And then looking at our slopes in between, positive, negative, positive. So, the only way to go from a positive number to a negative number is to go through 0. The only way to go from a negative to a positive is to go through 0. So once you have the zeros plotted, and you just sample anywhere in between, it's got to be that sign on that whole interval. Now let's put together 3 different plots. We got the plot of the function, and now we'll plot the slope numbers. So there I'll plot a positive number because I have a positive slope. Plot 0, 0 slope. Plot a negative number because I got negative slope. 0. And a positive. Connect the dots. And there's a rough sketch of y prime. Since this is a sketch, I can find the slopes. So there's where the slope is going to be 0, somewhere in between the 2 critical numbers, because at the critical numbers it's a positive and a negative slope, so it's got to be 0 in between. So y double prime of the first critical point is negative, y prime at the first critical point is 0, and that first critical point is a max. And then we do the same for minimum. So the minimum at the second critical point, the derivative is 0, the second derivative is a positive. This gives us our 2-stage test for calculating maximums and minimums. The first step, get your critical points. Find where your slopes are 0. So you set y prime equal to 0 and you solve. Once you have your critical points, you have to test them. So one way is to plug it in the second derivative, but we also looked at the sign change of the first derivative, and we also looked at just the shape of the function. All 3 ways are valid. Put it together as one little routine. Here we go. First step, get your critical point. Set the derivative equals 0, and you solve. Second, test your critical point. So we've had 3 different tests. We could either plug the critical point into y double prime, or we could look at the sign change on y prime, or we could just use the geometry. Just look at the graph of the function and point to it and go, yeah, that's a max, and that's a min. So let's do max first. So I graph the function, and I go, yeah, there they go. There's my maximum point right there. Looking at the slopes, I compute where it's 0, and I plug in a point on either side and see if it's positive or negative. So the sign change tells me. Or I can plug it in the second derivative if that's a negative. If I'm a negative person, I'm frowning. Oh, there you go, maximum shape. This is called the second derivative test. Looking at the sign change, that's your first derivative test. And looking at the graph, that's just the geometry definition. Do the same for mins. Graph the function, point to the point, go, yep, there's the min right there. Look at the sign change on the derivative. Plug in a point to the left, plug in a point to the right. Or I plug it into my second derivative and get a positive. If I'm a positive person, I'm smiling.